Now let us learn about upper bound and lower bound and what do these words mean or what do they signify. Suppose we do some measurement like measuring a length, measuring the height, or measuring weights, or even temperature. Whatever we measure, it may not be very accurate. Errors may occur because of several factors. It may be because you have a faulty equipment, the ruler is not graduated properly, or it may be due to parallax error, the thickness of the ruler, or even the weighing machine, there can be some error. So, generally, they will say it is given correct to one decimal place. The measurement is given correct to the nearest whole number. So they will specify to what degree of accuracy the measurement is given. So based on that, you can give a range. You will find a range of values between which the actual measurement will lie. For example, so the lesson is on lower bound and upper bound. Lower bound and upper bound. So why do we need this? This will give the range within which the certain value will lie. The measurement, say, if you are measuring a pencil, say, if you are measuring a pen, and that measurement is given to correct to the nearest whole number, you can say, oh, this length may not be accurate. It can be between this value and this value, a lower value and a higher value. So that range, the lower value is called the lower bound and the upper value is called the upper bound. And how do you fix this lower value and the upper value? That's what we are going to learn now. So, for example, if I say 1.5, it may be so many centimeters, 1.5 centimeters, given correct to one decimal point, is given correct to one decimal point. Then what are the range of values within which this can lie? Now take this, you write one decimal point is here and consider 0.1. So one decimal point, always take unity, that 1, 0.1, take half of that. What is half of 0.1? 0.05. So add 0.05 to the given value, you get the upper bound. Subtract 0.05, you get the lower bound. So lower bound will be, I'm going to write LB for lower bound. That will be 1.5 minus 0.05. Upper bound will be 1.5 plus 0.05. So what is the lower bound? 1.45. What is the upper bound? 1.55. So your measurement, say let us say x is the actual measurement, but you are given that as 1.5. It can lie between 1.45, you include that 1.45 and it is strictly less than 1.55. Don't put the equal to sign for this. So the measurement of that 1.5 can be a range of values. It can be a range of values between 1.45 and 1.55, but it is given to you as 1.5 correct to one decimal place. So on the number line it is 1.45. You shade that circle, and 1.55, it's an open circle. The value of that measurement can be anywhere here. But what is given to you is 1.5. Now let us take one more example where it is where you have to find we are going to find the upper bound and lower bound for these cases. Say a person's height is given as 177 centimeters correct to the nearest whole number. So this degree of accuracy will always be given to you when they ask you for upper bound and lower bound. So correct to the nearest whole number. So what is the upper bound and what is the lower bound? So for the nearest whole number, takes the ones digit and always take 1, the unit. And 1 divided by 2 is 0.5. Now the lower bound will be the 177 minus 0.5, and the upper bound will be 177 plus 0.5. So this is 100 and, what is that? 177 minus 0.5, 176.5, and this will be 177.5. So if you want to put it as an inequality, 176.5 less than or equal to x, which is the height, less than 177.5. The equal to is on the left, but the equal to is not on the right side of x. So the upper bound is 177.5, the lower bound is 176.5. So we will correct 0.3 is a sum measurement. Consider 0.3. It is some measurement given correct to one decimal place. Give the upper bound and the lower bound. So one decimal place we already saw 0.1. Divide that by 2. That will be 0.05. So your lower bound will be 0.3 minus 0.05. Upper bound will be 0.3 add 0.05. So you're on that 0.3, whatever that signifies, that will lie between 0.25 less than or equal to x less than 0.35. Now we'll see 100 and we'll take this weight now. Now 17.16 grams. This is the weight of some object. It is given correct to 2 decimal places. Now let us get the upper bound and the lower bound. Now correct to 2 decimal places, we will consider 0.01. Always write the unity. And that is divided by 2. Because 2 decimal places, here we take 0.01, that also has 2 decimal places, divide by 2. When I divide by 2, I get 0.005. So my lower bound will be 17.16 minus 0.005, and that is 17.155. Upper bound will be addition is easy, 0.005, that will be 17.165. So if they just ask you for lower bound, upper bound, you can leave it like that. But if they say show this as an inequality, now you will have to write the lower bound less than or equal to x less than 17.165. Now if they give this correct to 1 decimal place, given to the nearest whole number, we can do it. What about when it is correct to the nearest 10? Say for example, the distance from between 2 places is given as 730 meters, correct to the nearest 10. Nearest 10 meters. What could the upper bound be? What could the lower bound be? Nearest 10, you take 10, divide by 2, it is 5. So that 5, the lower bound will be 730 minus 5, which is 725 meters, and the upper bound will be 730 plus 5, that is 735 meters. And you know how to write the inequality. 725 less than or equal to x less than 735. This is the range of values for that distance. Now, instead of giving nearest 10, nearest whole number, correct to 1 decimal point, correct to 2 decimal point, they say correct to 1 significant figure, 2 significant figures. Then you need to be a little careful. Say, for example, if they say 0.840 is given, correct to 2 significant figures. You can see there are 2 significant figures here. So how do I get the upper bound and lower bound for this? You add one 0, that is, you take this as 0.002. You can take this as 0.01 and divide by 2, so that you get 0.005. You get 3 digits after the decimal point here. Then the lower bound, as usual, the lower bound will be 0.840 minus 0.005, and the upper bound will be 0.840 plus 0.005. So the lower bound will be 0.835, upper bound will be 0.845. So when the measurement is given correct to 2 significant figures, your lower bound and upper bound will have 3 significant figures. 3 figures. Now we'll also do this 640 given to 2 significant figures. Now the upper bound and the lower bound. So here we can take that 10 and then divide by 2, which will be 5. So lower bound will be 640 minus 5. Upper bound will be 640 plus 5. So this will be 635 and this will be 640.